On this video, we're going to go through the introduction to a circle. So we're just going to go over the definitions for diameter, radius, and chord. So the diameter of a circle is the segment passing through the center with both endpoints on the circle. So you can see over here, and you should have this on your piece of paper too. You have a circle, and you want to draw from one side to the other, but it needs to go through the center. And it doesn't have to go this direction. It can go any direction through the circle as long as it goes from one side to the other through that center. So if it doesn't go through the center, it's got a different name, which we'll talk about in just a second. Okay, so it's a special segment that goes through the center, but also goes from side to side. All right. The radius of a circle is a segment whose endpoints are the center and a point on the circle. So now I don't go all the way from side to side. I go from the center to the side. And again, it can go in any direction around the circle here as long as it starts at the center and goes to the side. Okay? Is there a relationship between the diameter and the radius? So if we kind of think about this, and I say, well, this goes from side to side through the center, and the radius goes from the center to the side. If I look at the diameter, well, if I go from the center to the side, that's one radius. If I go from this center to the other side, that's another radius, right? So the diameter is made of 2 radii. So D equals 2R, so diameter equals 2 radius, right? So with this one, in a problem, if we're given the diameter and we need the radius, we can simply divide by 2, right, to go down to radius. Or if we're given the radius and we need the diameter, I can multiply by 2, right? So I can go back and forth with these two because they have a relationship. All right, the very last one is a chord of a circle is the segment with both endpoints on the circle, but not necessarily going through the center. So a diameter is a special chord, right? But it has a special name. So if it goes through the center, it's not just a chord, now it's a diameter. But if it doesn't go through the center, it just goes from side to side like this, and again, it can be anywhere in the circle, we call this a chord. All right, so let's go ahead and look at the Alex problem. So a circle with center I is shown in the figure below. So we have I, and we have all of these segments going around, and they're going to have us name a diameter, a radius, and a chord. And then they're also going to have us work out a little problem here. So a diameter, remember that needs to go from side to side, but it has to go through the center. So I really only have one option. It's going to be KJ. I could also say that this is JK. I can label it either way that I want to. You could use I as part of your label, but generally when we're doing the segment for the diameter or the radius, we use the beginning and the end of it. So a radius, there are actually quite a few different options for radius on this one. The easiest one to kind of see really quickly is this one that goes from center to side. But remember, a diameter is also made up of 2 radii. So KI is also a radii, or JI is also a radii, or I could say IL, IK, or IJ. I can switch the letters around, beginning and end. That's not going to change anything. So those are my 3 options there. And again, technically there's 6 options because I could switch the letter orientation. Like I could have LI, KI, or JI. All right, a chord. So we have the chord that's kind of the obvious chord here going from side to side but not through the center. But remember, a diameter is also a chord. So I have 2 options that I could choose here. I could choose the NM or I could choose the JK again. And again, yes, you can switch the letters. So I could say MN or JK. So a couple of different options for each one of these. This one really the only option is to switch the letters around, just to, instead of going KJ, go JK, but still, they all have options there. So now if the length of JK is 4 units, what is the length of IL? So if I have JK here, and that's a diameter of 4 units, remember a diameter is equal to 2 radii because it literally is 2 radii back to back. So KJ is our diameter, IL is a radius, right? This is just a radius. It's not one of the radius attached to that diameter, but it doesn't matter. All the radii in the circle are exactly the same. They're all congruent to each other because they're all going from the center to the side. And the whole idea of a circle, I know I didn't go over that earlier for the definition, but a circle is all the points that are equidistant from a center. So all of the whole line we see going around here, that's all the same distance from I, no matter where I go around the circle. So now if I plug this in, I have 4 equals 2 times IL, and I'm just going to divide by 2 on both sides to figure out what my radius has to be. And this is any radius in this circle. All right, so that is the introduction to a circle. I hope that helped, and I'll see you in the next video.